Betelgeuse. Not the mischievous ghost from movies, but the real celestial titan. A red supergiant star burning at the edge of collapse. Place it where our Sun is, and it would stretch beyond Mars, beyond the asteroid belt, all the way to Jupiter's orbit. That's how monstrously huge it is. It's a cosmic behemoth, beautiful, brilliant, and dangerously unstable. 600 light-years from Earth, this red giant is nearing the end of its life. And the universe might be about to witness one of the most spectacular events in modern astronomy, a supernova. But here's the twist. Google may have just modeled the exact moment this star will explode. A quiet experiment in a quantum lab sent shockwaves across the digital cosmos. TikTok lit up, Reddit threads exploded, and science forums buzzed with disbelief. It wasn't just a simulation. It was something far more profound. A quantum experiment that might have peeked into the future. At the heart of this viral phenomenon lies Google's advanced quantum systems, processors with names like Sycamore and Willow. What if a computer so powerful it could solve problems older than the universe itself, just glimpsed the death of a star? That's what people believe may have happened with Betelgeuse, a star watched by scientists, dreamers, and poets for centuries. Not just because it's massive or red or old, but because it might explode in our lifetime. So, what exactly is this quantum core that people are obsessing over? The name itself sounds like sci-fi. But it's shorthand for Google's revolutionary quantum processors, capable of calculations far beyond classical machines. In 2019, Google announced Sycamore, a 53-qubit chip, had achieved quantum supremacy. It solved a problem in 200 seconds that would take the world's best supercomputer over 10,000 years. Then came Willow, a 105-qubit marvel introduced in 2024. It cracked a problem that would take classical computers longer than the age of the universe. And that's where boundaries started to blur. Between science and science fiction. Between now and the future. Because at this level of power, we're not just crunching numbers anymore, we're decoding nature itself. Quantum computers speak the same language as stars. Subatomic particles. Fusion reactions. The chaos at the heart of supernovas. And while classical computers struggle with the vast, chaotic equations inside stars, quantum systems may someday simulate them natively. It's not just computing, it's digital astronomy, quantum style. But did Google really simulate Betelgeuse's explosion? Or are we witnessing another internet myth born from truth and wrapped in speculation? Let's separate fact from fiction. Yes, Google's quantum computers have accomplished stunning feats. They've simulated quantum magnetism and tiny molecules. But modeling a star like Betelgeuse is an entirely different scale. Trillions upon trillions of interacting particles, all governed by quantum rules. The leap is enormous. Like going from simulating a ripple in a pond to predicting a planetary tsunami. Still, the principles are the same. Tiny simulations today could become massive, not yet. But something had changed. Betelgeuse returned to its glow, a little less steady, a little more haunted. As if the cosmos had whispered, not today, but soon, and the world moved on. Or tried to. But beneath the headlines and fading tweets, something stirred, a new scientific obsession. What if the real story wasn't about Betelgeuse exploding, but about when it might? Because now, the question wasn't if a supernova could be simulated, it was how far ahead we could see. Could quantum computers do more than just crunch probabilities? Could they see through time? This is where things get wilder. Not science fiction, but quantum mechanics itself. In the quantum world, time is slippery. Particles exist in superpositions. Causes don't always lead to effects. And sometimes, the future leaks backward. In fact, there's a theory, retrocausality, that suggests particles can be influenced by future events. Wrap your head around that. Not cause then effect, but effect then cause. And suddenly, the viral rumor of Betelgeuse being predicted didn't feel so absurd. It felt like a glimpse. An accidental peek behind the curtain. But it didn't stop there. The same week the internet exploded with Betelgeuse rumors. Physicists working with Google's quantum chip observed something strange. An experiment meant to simulate particle decay started giving unexpected results. Data patterns that didn't align with anything known. No error. No malfunction. Just a moment where the math didn't match reality, or maybe revealed a new one. It didn't go public. Not officially. But whispers emerged, in private Slack groups, in peer review side notes, that perhaps the system had modeled a phenomenon that hadn't happened yet. That perhaps the chip had peeked into a quantum landscape that included the future. And once that idea took hold, everything changed. New labs emerged, not just to simulate particles, but to simulate time. To build chronoscopes, quantum engines designed to scan probable timelines. To map out stellar deaths. Collisions. Even the emergence of new black holes. Call it digital prophecy. Call it quantum astrology. Call it madness. But scientists had tasted something intoxicating. Prediction not through pattern, but through physics. And Betelgeuse? It became a benchmark. Every new quantum model was tested on it. Could it replicate the dimming of 2019? Could it predict the next phase pulse? Could it pinpoint, to the year, the month, when the supernova would ignite? Some models said 2025. Others, 2031. One model, running on an experimental Chinese quantum system, claimed 2027. March. It was dismissed. But someone printed it. Framed it. Hung it in the control room of a telescope in Chile. Because maybe, just maybe, it would be right. Meanwhile, a new question emerged. What if we could simulate not just the death of a star, but the birth of one? Quantum computing wasn't just about observation anymore. It became about intervention. In secret research facilities buried beneath mountain observatories, a new class of experiment began. Controlled quantum simulations of stellar nurseries. Trying to coax hydrogen clouds into fusion in a sandbox universe. Trying to shape creation itself, one equation at a time. Some called it the God algorithm. Others, the digital forge. But one thing was clear. This was no longer about watching stars die. It was about building them. And Betelgeuse? It became the first, the omen, the warning, the beginning. Not the end of a story, but the spark that lit an age of quantum exploration. Because once we could simulate a supernova, what's next? Simulate entire galaxies? Black hole mergers?